This is Algebra 1, Lesson 33b, Statements about Unequal Quantities. We're going to do examples 33.3 through 33.6. Example 33.3. Twice a number is 42 less than negative 102. Find the number. Now the book explains this in slightly a different way. I'm going to do it the way we've done it the last two sections, where we started by learning how to take a verbal phrase and turn it into an algebraic expression. And then in another lesson, we took a verbal phrase and turned it into an algebraic equation where the two sides are equal. This one is going to tell you that the sides are not equal, but there's a way to handle that, okay? So let me show you what I mean. Twice a number, okay, twice a number is, and it's not telling me that it is equal to here, it's telling me it is 42 less than something, okay? So here's how I handle that. I say it is equal to this if you took 42 away from it. Does that make sense? Twice a number, and the number is n, is 42 less than, okay, 42 less than, so I'm going to have to subtract 42 away from something. Well, what is the something? It's the negative 102. So I have 2n equals negative 102 minus 42. Now, what can I do here? Well, I don't have parentheses, but I can combine like terms here. So let's do that. I have 2n is equal to negative 102 plus a negative 42, which would be negative 144. I'm multiplying the variable by 2, so let's divide by it. And then I'm going to have n is equal to negative 72. So that should be our number, and we can check it. Twice a number, so let's do negative 72 times 2, and that's going to be negative 144, is 42 less than negative 102. So 42 less than negative 102 would be negative 144. And we end up with the correct answer. It checks. So it's really doing it this way is the same as what we have been doing, and I find that students seem to get confused less easily. They are able to do it better if we do it this way. So let's try it with number 4. 5 times a number, so the number is going to be n. So 5 times a number is going to be 5n, and they tell us it is 72 greater than. Okay, so this expression is 72 greater than something. What is the something? The opposite of the number. The opposite of the number. So if I take that and begin to simplify it, I can see here that I don't have any like terms on either side, but I do have a variable on both sides. So what I want to do is I want to get the variables on one side. I need to get rid of one of those. So I can either subtract the 5n or I can add in. And you know I'm going to choose to add in because that makes it much easier. 5n plus 1n is 6n equals 72. Now what I'm going to do is they're multiplying by 6, so I'm going to divide by 6. And I find out that n is equal to 12. And you can check that. 5 times 12 is 60. And that's 72 greater. Let's see, wait, am I doing that right? 5 times the number is 72 greater than the opposite of the number. Yes, that's right. So 5 times 12 is 60, and then 72 plus the opposite of the number, which would be negative 12, would add up to 60. So that's right. All right, 33.5. If the sum, so we're going to be adding some things, of twice a number, and the number is n. So the sum is twice a number and what? Negative 14. if the sum of twice a number and negative 14 is multiplied by 2. Now, careful here. The sum is multiplied by 2. So we're going to have to find the sum. So we indicate that by putting parentheses and then multiply that sum by 2. The result is 12 greater than the opposite of the number. Now we're going to simplify. We have parentheses on the left side, so let's go ahead and distribute because we can't do what's inside of these parentheses. So I'm going to have 4n, when I multiply here, and then I have plus a negative 28, or that would be a minus 28, equals, and I can simplify this a little bit, 12 minus n, because it's plus, the opposite of n. So I've got variables on both sides. I want to go ahead and get rid of one of those. So I believe I'm going to go ahead and add n. I could have subtracted 4n from both sides. 4n plus 1n is 5n. Minus 28 equals 12. Now I want to get rid of the constant term with the variable. So I'm going to add 28 to both sides. And I end up with 5n is equal to, what is that, 40? Now I'm multiplying by 5, so I'm going to divide both sides by 5. And I get n is equal to 8. And that is your answer. And we can check that. We can substitute that back in. If the sum of twice a number, so I'm going to check it here, the sum of twice the number and negative 14 is multiplied by 2. So we'll upgrade that to some brackets. Okay. That result. So let's find that result. This is going to be 16 plus negative 14. And then that's doubled. So we're going to get 4 on that side. Okay. That result is 12 greater than the opposite of the number. And the number is 8. 12 plus a negative 8 is going to give you 4. So it works. All right, 33(6), our last example. The number is going to be n. 5 times a number is 21 less than. Now remember, it's not this, okay? If you're doing 21 less than, you have to subtract 21 from it. 21 less than twice the opposite of the number. Less than 20, twice the opposite of the number. So let's simplify that a little bit. 5n is equal to, I would change that to negative 2n, because remember there's a 1 here, so that's just negative 1 times 2, which is negative 2, and then times n. All right, now I have variables on both sides. I could subtract 5n from both sides or add 2n to both sides. I believe I'm going to add 2n to both sides. And I get 7n is equal to negative 21. They're multiplying the variable by 7, so let's divide the variable by 7. N is equal to negative 3. Let's check it. 5 times the number, and that's going to be negative 15, is going to be 21 less than twice the opposite of the number. Well, if the number is negative 3, the opposite of the number is going to be 3. And twice that would be 6. Whoops. And 6 minus 21 would be negative 15. So it works.